My name is Frank Hegmann, and I'm a professor here in the Department of Physics.
Hello, I'm Marie-Cécile Piro, assistant professor in the Department of Physics at University of Alberta.
And we're going to show you today a whole bunch of physics demonstrations that we think are pretty cool. Starting with the Van de Graaff generator, which is some of everybody's favorite. So when I turn on this Van de Graaff, it generates a high voltage, and we can make some really cool sparks, which are always fun.
Whoa!
And I can turn that off and give it a good shock too. And we'll just make sure that's completely neutralized. And then we're going to try a quick experiment with a bunch of aluminum foil pie dishes, and we're going to see what happens when we start charging up these metal films. So turn it on, and stand back, and
whoa! Wow!
I got shocked again. So as they got charged, they started repelling each other, because like charges repel. And that's your...
But everyone's favorite is...
using static electricity to make your hair go up. Uh-oh, is that... What's happening? Okay, you can turn it off now.
Here we have the magnetic levitation demo. All around here you can see we have magnets. And by cooling this special metal here and cool enough, we will make it as supraconductor. I will put now the liquid nitrogen. Maybe a little bit more, and let's see what happens.
This is another quantum experience with levitation, but with two types of magnets.
So this is one of the second-year labs, and one of the experiments that you'd be doing as an undergraduate student in physics is the E/m, or charge-to-mass ratio of the electron. And here you can see an evacuated tube where you can actually see the electron beam. So if we should turn off the lights, you'll be able to zoom in on the vacuum chamber. So the blue glow you see inside is the electron beam traveling in just a little bit of gas inside this evacuated tube, and it's actually in a traveling in a circular orbit due to a magnetic field. And if I increase the magnetic field, the radius of that orbit decreases. And from those measurements, you can actually measure the charge to mass ratio of the electron. But it's also pretty cool that you can actually see an electron beam moving in this vacuum.
Here we have a cup that is cold and a cup that is hot. How are we gonna know which one is cold and which one is warm without touching it? We use the thermal imaging gun. So here you can see the thermal imaging of my body, where the clearer, brighter is hot and darker is cold. For example, my nose is more darker than my face. Now let's have a look of the cups. You can see here, this one is much brighter than the other one. So this one is warmer than this other one. In fact, here we have hot water, and here we have liquid nitrogen. Cheers! So this demonstration will show you how the light is emitted from each element. And you have here gas discharge, where each element has its own fingerprint of light emission. So if we are going to start with the hydrogen, you can see here the light, and thanks to diffraction gradient, we can see really all the spectrum emitted by the hydrogen. So let's have a look together. So let's first see the light emission of a cell phone. So you can see here, it will appear a rainbow. So it's mostly white light. Now let's see for the hydrogen. Okay, so now let's have a look of neon. And again, if you look at on your left, you can also see the light. And this is the same for each gas. So now, if we are looking for mercury, again, you go to your left, and you can see all the lines. That's very nice flower. I wonder what happens if I put it in the liquid nitrogen. Let's do a test. Ooh la la! Oh. It starts to be very... Oh! Oh my god!